Hello. Geography of Turkey 1. Welcome to the Physical Geography of Turkey course. In today's session, we will discuss the basic factors and processes in the formation of landforms. Landforms are the result of various geological and geomorphological processes that shape the Earth's surface over long periods. Here are some of the key processes contributing to the formation of different landforms. 1. Plate tectonics. Mountain ranges, formed by the collision of tectonic plates, leading to the uplift of the Earth's crust. Valleys and rifts result from the movement of tectonic plates away from each other. 2. Weathering and erosion. Mountains and hills, shaped by the breakdown of rocks due to weathering and sculpted by erosion from wind, water, and ice. Canyons and valleys, carved by the erosive action of rivers and glaciers. 3. Deposition. Plains, accumulation of sediments, often from rivers, forming flat or gently rolling landscapes. Deltas, formed at the mouths of rivers where sediments are deposited. 4. Volcanic activity. Volcanic mountains, created by the accumulation of lava, ash, and other volcanic materials. Calderas and craters, formed by the collapse of volcanic structures. 5. Glacial processes. Glacial valleys and fjords, carved by the movement of glaciers. Moraines and drumlins, deposits left behind by glaciers. 6. Karst processes. Caves and sinkholes, result from the dissolution of soluble rocks like limestone. 7. Tidal and coastal processes. Coastal features, such as beaches, cliffs, and sea stacks formed by the action of waves, tides, and currents. 8. Impact events. Craters, created by the impact of meteorites or asteroids. 9. Human activities. Anthropogenic landforms, cities, dams, canals, and other structures created by human activities. These processes often interact and overlap, leading to the diverse range of landforms observed on Earth. The geological history of a region and the ongoing interplay of these processes contribute to the dynamic nature of landscapes. External processes, also known as exogenic processes, refer to the geological processes that primarily occur on the Earth's surface and are powered by external forces such as weathering, erosion, transportation, and deposition. These processes play a crucial role in shaping the Earth's landforms and modifying its surface features. Here's a brief overview of some key external processes. 1. Weathering. Definition: weathering is the breakdown of rocks into smaller particles at or near the Earth's surface. Types: there are two main types of weathering: mechanical, physical, weathering and chemical weathering. Mechanical weathering involves the physical breakdown of rocks into smaller fragments without changing their chemical composition. Chemical weathering involves the alteration of rock minerals through chemical reactions. 2. Erosion. Definition: erosion is the process by which weathered rock and soil particles are removed from one place and transported to another by natural agents such as water, wind, ice, or gravity. Agents: different agents of erosion include water, rivers, streams, wind, glaciers, and gravity. 3. Transportation. Definition: transportation involves the movement of eroded particles by various agents to new locations. Modes: particles can be transported by water, as sediment in rivers or oceans, wind, as airborne particles, ice, glacial movement, or gravity, downslope movement. 4. Deposition. Definition: deposition is the settling or dropping of transported particles due to a decrease in the energy of the transporting medium. Features: deposition leads to the formation of various landforms such as river deltas, alluvial plains, sand dunes, and moraines. These external processes interact with each other and contribute to the continuous reshaping of the Earth's surface. For example, weathering breaks down rocks into smaller particles, erosion transports these particles, and deposition results in the accumulation of sediments in new locations, forming diverse landforms. Fluvial-alluvial processes refer to the geological and geomorphological activities associated with rivers and their interactions with sediment transport, deposition, and landform development. Here's a brief overview. 1. Fluvial processes. Erosion. Rivers erode the landscape by carrying away sediment, primarily through processes like abrasion, hydraulic action, and attrition. Transportation. Sediments, such as gravel, sand, and silt, are transported downstream by the river's flow. Larger particles are typically transported near the riverbed, while smaller particles may remain in suspension. Deposition. sediments are deposited when the river's energy decreases. Depositional features include riverbanks, floodplains, and deltas. 2. Alluvial processes. Alluvium formation. Alluvial processes involve the deposition of sediment by flowing water. Alluvium refers to the sorted material, sand, gravel, silt, deposited by rivers and streams. Floodplains. When rivers overflow their banks during floods, they deposit alluvial material on adjacent floodplains. This process contributes to the development of fertile soils. Delta formation. Deltas are formed at the mouths of rivers where sediment carried by the river is deposited as it enters a standing body of water, such as a lake or sea. 3. Landforms resulting from fluvial-alluvial processes. River valleys. Erosion by rivers can create V-shaped valleys, and continued erosion can lead to the formation of canyons. Floodplains. Extensive, flat areas adjacent to rivers formed by alluvial deposition during floods. Deltas. Triangular-shaped landforms at the mouths of rivers, where sediment is deposited into a larger body of water. Alluvial fans. Cone-shaped deposits of sediment at the base of a mountain, often formed by streams emerging from mountainous terrain. These processes are dynamic and continually shape the Earth's surface over time. The specific characteristics of fluvial-alluvial features depend on factors such as the type of sediment, the gradient of the land, and the volume and velocity of water flow. Turkey, with its diverse topography and extensive river networks, exhibits various fluvial landforms shaped by the interaction of rivers and their surrounding environments. Here are some notable fluvial landforms in Turkey. 1. Köprülü Canyon. Köprülü Canyon, located in the Antalya province, Köprülü Canyon is a spectacular river canyon formed by the Köprü River. The canyon is known for its impressive rock formations and is a popular destination for whitewater rafting. 2. Sakarya River Valley. The Sakarya River, one of Turkey's major rivers, has carved a wide valley in the northwestern part of the country. The river valley is characterized by fertile plains and meanders, contributing to agricultural activities in the region. 3. Euphrates and Tigris River Basins. The Euphrates and Tigris rivers, originating in eastern Turkey, create extensive fluvial landscapes. The river basins support rich agricultural areas, and their interaction has led to the formation of floodplains and wetlands. 4. Dikil, Tigris, River Canyon. The Dikil River has carved a deep canyon in southeastern Turkey. The canyon features rugged cliffs and steep slopes, offering stunning natural scenery. 5. Göksu River Delta. Situated on the Mediterranean coast, the Göksu River forms a delta with diverse ecosystems, including wetlands and lagoons. The delta is an important habitat for various bird species and supports biodiversity. 6. Maris River Delta. The Maris River, flowing along the Turkish-Greek border, creates a delta before entering the Aegean Sea. The delta area is characterized by marshes and wetlands, providing vital habitats for flora and fauna. 7. Melen River Valley. The Melen River, located in the northwest, has shaped a scenic valley known for its meandering course. The valley is surrounded by hills and offers picturesque landscapes. These fluvial landforms highlight the geological and geomorphological diversity influenced by Turkey's complex tectonic and climatic conditions. The country's rivers play a crucial role in shaping both natural landscapes and human activities. In hillslope geomorphology, a rill is a shallow channel, no more than a few inches/decimeters deep, cut into soil by the erosive action of flowing surface water. Similar but smaller in size channels are known as microrills, larger in size channels are known as gullies. Water flowing in an actively eroding rill on bare farmland in County Tyrone, Northern Ireland. Rills are narrow and shallow channels which are eroded into unprotected soil by hillslope runoff. Since soil is regularly left bare during agricultural operations, rills may form on farmland during these vulnerable periods. Rills may also form when bare soil is left exposed following deforestation, or during construction activities. Rills are fairly easily visible when first incised, so they are often the first indication of an ongoing erosion problem. Unless soil conservation measures are put into place, rills on regularly eroding areas may eventually develop into larger erosional features such as gullies or even, in semi-arid regions, into badlands. A gully is a landform created by running water, mass movement, or commonly a combination of both eroding sharply into soil or other relatively erodible material, typically on a hillside or in river floodplains or terraces. Gullies resemble large ditches or small valleys, but are meters to tens of meters in depth and width, are characterized by a distinct headscarp or headwall and progress by headward, i.e. upstream, erosion. Gullies are commonly related to intermittent or ephemeral water flow, usually associated with localized intense or protracted rainfall events or snowmelt. Gullies can be formed and accelerated by cultivation practices on hillslopes, often gentle gradients, in farmland, and they can develop rapidly in rangelands from existing natural erosion forms subject to vegetative cover removal and livestock activity. A valley is an elongated low area often running between hills or mountains, which will typically contain a river or stream running from one end to the other. Most valleys are formed by erosion of the land surface by rivers or streams over a very long period. Some valleys are formed through erosion by glacial ice. These glaciers may remain present in valleys in high mountains or polar areas. At lower latitudes and altitudes, these glacially formed valleys may have been created or enlarged during ice ages but now are ice-free and occupied by streams or rivers. In desert areas, valleys may be entirely dry or carry a watercourse only rarely. In areas of limestone bedrock, dry valleys may also result from drainage now taking place underground rather than at the surface. Rift valleys arise principally from earth movements, rather than erosion. Many different types of valleys are described by geographers, using terms that may be global in use or else applied only locally. River valleys. The development of a river valley is affected by the character of the bedrock over which the river or stream flows, the elevational difference between its top and bottom, and indeed the climate. Typically the flow will increase downstream and the gradient will decrease. In the upper valley, the stream will most effectively erode its bed through corrosion to produce a steep-sided V-shaped valley. The presence of more resistant rock bands, of geological faults, fractures, and folds may determine the course of the stream and result in a twisting course with interlocking spurs. In the middle valley, as numerous streams have coalesced, the valley is typically wider, the flow slower and both erosion and deposition may take place. More lateral erosion takes place in the middle section of a river's course, as strong currents on the outside of its curve erode the bank. Conversely, deposition may take place on the inside of curves where the current is much slacker, the process leading to the river assuming a meandering character. In the lower valley, gradients are lowest, meanders may be much broader and a broader floodplain may result. Deposition dominates over erosion. A typical river basin or drainage basin will incorporate each of these different types of valleys. Some sections of a stream or river valleys may have vertically incised their course to such an extent that the valley they occupy is best described as a gorge, ravine, or canyon. Rapid down-cutting may result from localized uplift of the land surface or rejuvenation of the watercourse as a result, for example, of a reduction in the base level to which the river is eroded, for example lowered global sea level during an ice age. Such rejuvenation may also result in the production of river terraces. A V-shaped river valley is a common landform created by the erosional forces of a river over an extended period. Here are the key characteristics and processes associated with V-shaped river valleys. Characteristics. 1. Steep sides. V-shaped valleys have steep, sloping sides that form an inverted V shape when viewed from above. The steepness is a result of the downward erosion of the river. 2. Narrow bottom. The valley floor or bottom is typically narrow compared to the width of the valley at the top. It is often occupied by the river channel. 3. Interlocking spurs. The eroded ridges that project into the valley from both sides are known as interlocking spurs. These spurs result from the river's inability to cut through the resistant rock features. 4. Vertical erosion. The primary erosional force shaping V-shaped valleys is vertical erosion, where the river cuts downward into the landscape, deepening the valley. Formation process. 1. Downcutting. The river primarily engages in downcutting, eroding the valley floor vertically. This is often facilitated by the force of flowing water carrying sediment. 2. Weathering. The sides of the valley undergo weathering processes, including freeze-thaw weathering and chemical weathering, which gradually break down the rock. 3. Mass movement. Weathered material and rock debris fall or slide down the steep valley sides due to gravity, contributing to the V shape. 4. Interlocking spurs. As the river encounters resistant rock features, it winds its way around them, creating interlocking spurs that extend into the valley. 5. Youthful stage. V-shaped valleys are characteristic of youthful river landscapes, where the river is actively downcutting and shaping the landscape. V-shaped river valleys are often associated with early stages of river development and are prevalent in regions with active erosional processes. Over time, as the river matures, the valley may evolve into a wider U-shaped valley through various geomorphic processes. A U-shaped river valley is a distinctive landform characterized by a broad, gently sloping bottom and steep, straight sides that resemble the shape of the letter U. Here are the key characteristics and processes associated with U-shaped river valleys. Characteristics. 1. Wide bottom. U-shaped valleys have a broad and flat valley floor, which is wider compared to the top of the valley. This width is often the result of glacial erosion. 2. Steep sides. The sides of the valley are characterized by steep and straight slopes, often carved out by glacial activity. The steepness is a result of the erosive forces of glaciers. 3. Smooth valley floor. Unlike V-shaped valleys, U-shaped valleys have a smoother and flatter valley floor due to the grinding action of glaciers. 4. Distinctive cross-section. When viewed in cross-section, the valley displays a U-shape, with gently sloping sides meeting at a relatively flat bottom. Formation process. 1. Glacial erosion. The primary process responsible for the formation of U-shaped valleys is glacial erosion. During periods of glaciation, large masses of ice, or glaciers, move through the landscape, carving out and shaping valleys. 2. Plucking. Glacial ice acts like a giant bulldozer, plucking rocks and debris from the valley walls and floor as it moves. This process contributes to the steepness of the valley sides. 3. Abrasion. The glacier grinds against the valley floor and walls, abrading and smoothing the surfaces. This results in the characteristic smoothness of the valley floor. 4. Ice flow. The movement of the glacier, especially its ability to flow and conform to the existing landscape, helps shape the U-shaped form of the valley. 5. Postglacial modification. After the retreat of glaciers, U-shaped valleys may undergo further modification by rivers and other erosional processes, contributing to their final form. U-shaped valleys are typically associated with regions that experienced past glacial activity, and they are common features in areas that were once covered by ice sheets or alpine glaciers. A flat-floored valley, also known as a flat-bottomed valley or alluvial valley, is a landform characterized by a relatively level and flat valley floor. Here are the key characteristics and processes associated with flat-floored valleys. Characteristics. 1. Flat valley floor. The most distinctive feature of a flat-floored valley is its flat and level bottom. The valley floor may extend over a considerable width, providing a relatively even surface. 2. Low gradient. Flat-floored valleys typically have a low gradient or slope, contributing to the flatness of the valley floor. The gentle slope allows for the accumulation of sediment. 3. Alluvial deposits. The flat valley floor is often the result of the deposition of sediments, such as sand, silt, and clay. These materials are transported and deposited by rivers, streams, or other water-related processes. 4. Meandering rivers. In some cases, flat-floored valleys are associated with meandering rivers. Meanders contribute to the development of a broad and flat valley floor through lateral erosion and sediment deposition. 5. Fertile soils. The deposition of alluvial sediments on the flat valley floor can lead to the formation of fertile soils, making these areas suitable for agriculture. 6. Vegetation. Flat-floored valleys may support lush vegetation due to the availability of water, fertile soil, and favorable topography. Formation process. 1. River deposition. The primary process leading to the formation of a flat-floored valley is the deposition of sediments by rivers. Rivers transport sediment downstream and deposit it on the valley floor when the flow velocity decreases. 2. Floodplain development. Flat-floored valleys often have well-developed floodplains, which are periodically inundated during floods. The deposition of fine sediments during flood events contributes to the flatness of the valley floor. 3. Erosion and sediment transport. While rivers erode and transport sediments, the balance between erosion and sediment deposition in the valley can lead to the creation of a flat-floored landscape. Flat-floored valleys are common in areas where rivers or streams have shaped the landscape through processes of erosion, transportation, and deposition, resulting in a relatively level valley floor. A rift valley is a linear-shaped lowland between highlands or mountain ranges, typically formed by the extension or splitting of the Earth's crust. Rift valleys are often characterized by unique geological features and are associated with tectonic plate movements. Here are key characteristics and processes related to rift valleys. Characteristics. 1. Linear shape. Rift valleys have a distinctive linear or elongated shape. They can extend for hundreds or even thousands of kilometers. 2. Steep cliffs or faults. The flanks of rift valleys are often marked by steep cliffs or fault scarps. These steep sides are created by the movement of tectonic plates. 3. Down-dropped block. In a rift valley, one side of the crust drops down relative to the other, creating a down-dropped block. This is known as a graben. 4. Block faulting. Rift valleys are formed through block faulting, where the Earth's crust is stretched and broken, leading to the subsidence of blocks of crust. 5. Volcanic activity. Rift valleys are commonly associated with volcanic activity. Magma rising from the mantle can reach the surface, creating volcanic features such as cones and lava flows. 6. Lakes. Rift valleys often contain lakes, which can form in the down-dropped blocks or along the rift zone. These lakes are sometimes referred to as rift lakes. Formation process. 1. Tectonic rifting. The primary process leading to the formation of a rift valley is tectonic rifting. It occurs when tectonic plates move away from each other, creating a zone of extensional stress. 2. Crustal stretching. As tectonic plates move apart, the Earth's crust undergoes stretching and thinning. This process is often associated with mantle upwelling. 3. Formation of faults. Faults develop along the rift zone, causing the crust to break and drop down in blocks. The central block, or graben, becomes the rift valley. 4. Magma upwelling. The stretching of the crust may allow magma to rise from the mantle, leading to volcanic activity along the rift. This can result in the creation of new crust. 5. Continued extension. Rift valleys may continue to widen and deepen over geological time as tectonic forces continue to act on the region. Prominent examples of rift valleys include the East African Rift, the Rhine Graben in Europe, and the Baikal Rift Zone in Siberia. A canyon valley, commonly known as a canyon, is a deep, narrow, and steep-sided valley carved by the erosive action of a river or other natural processes over a long period. Canyons often exhibit dramatic landscapes with vertical cliffs and unique geological features. Here are key characteristics and processes related to canyon valleys. Characteristics. 1. Steep walls. Canyons are characterized by steep and often vertical walls, forming deep incisions into the Earth's surface. 2. Narrow width. Canyons typically have a narrow width compared to their depth, creating a distinct and elongated shape. 3. Rock formations. The walls of canyons often expose various rock layers, showcasing the geological history of the region. Different rock types may contribute to the canyon's unique colors and patterns. 4. River or stream. The formation of canyons is often associated with the erosive action of a river or stream. The flowing water cuts through the rock, deepening and widening the canyon over time. 5. Scenic beauty. Canyons are renowned for their scenic beauty, with breathtaking views and landscapes. They attract tourists, hikers, and geologists alike. Formation process. 1. Erosion. The primary process leading to canyon formation is erosion, which can occur through various agents such as rivers, streams, wind, and ice. 2. River erosion. In many cases, canyons are formed by the erosive power of rivers or streams. The flowing water carries sediments and abrasives that gradually wear away the rock, cutting into the landscape. 3. Downcutting. The downward cutting action of the river is crucial in carving the canyon. Over time, the river deepens its channel, creating the steep walls of the canyon. 4. Headward erosion. Canyons may also form through headward erosion, where a river cuts into the landscape at its upper reaches and extends its course upstream, progressively deepening the canyon. 5. Tectonic activity. Some canyons may be influenced by tectonic activity, where Earth's crust experiences uplift or subsidence, exposing rocks to erosion by rivers. 6. Weathering. Weathering processes, including freeze-thaw cycles and chemical weathering, contribute to the breakdown of rock within the canyon walls. Prominent examples of canyons include the Grand Canyon in the United States, the Fish River Canyon in Namibia, and the Tara River Canyon in Montenegro. Each canyon tells a geological story shaped by the intricate interplay of erosional forces over millions of years. Alluvial landforms are geological features created by the deposition of sediments carried by rivers, streams, and other water bodies. These landforms are often found in areas where water flow is prevalent, and they result from the transportation and settling of sediment over time. Here are some common types of alluvial landforms. 1. Alluvial fans. Alluvial fans are cone-shaped deposits of sediment that form at the base of mountains or hills where fast-flowing rivers exit narrow valleys. Sediments, such as gravel and sand, spread out as the river loses energy, creating a fan-shaped pattern. 2. Floodplains. Floodplains are flat, low-lying areas adjacent to rivers that periodically flood. Sediments carried by the river during floods are deposited on the floodplain, creating fertile soil. 3. River deltas. Deltas form at the mouths of rivers where they meet standing bodies of water, such as oceans or lakes. Sediments carried by the river are deposited, forming a triangular or fan-shaped delta. 4. Point bars. Point bars are deposits of sediment found on the inside bend of meandering rivers. As the river flows, it erodes the outer bend, cut bank, and deposits sediment on the inner bend, creating a point bar. 5. Levees. Levees are natural embankments along the sides of a river, formed by the accumulation of sediment during floods. They act as natural barriers, confining the river within its channel. 6. Oxbow lakes. Oxbow lakes are crescent-shaped water bodies that form when a meandering river cuts off a meander bend, creating a cutoff or oxbow lake. 7. Braided rivers. Braided rivers have multiple interconnected channels that divide and rejoin, creating a braided pattern. Sediment is deposited on the riverbed, forming islands and bars. 8. Terraces. River terraces are flat, elevated surfaces alongside a river, formed by the erosion and downcutting of a river, followed by the deposition of sediment. 9. Backswamps. Backswamps are low-lying, poorly drained areas behind natural levees on a floodplain. They often retain water after floods and contribute to the overall diversity of the floodplain. Alluvial landforms play a crucial role in shaping landscapes and supporting various ecosystems by providing fertile soils and habitats for diverse plant and animal life. Alluvial fans. Alluvial fans are cone-shaped deposits of sediment that form at the base of mountains or hills where fast-flowing rivers exit narrow valleys. Sediments, such as gravel and sand, spread out as the river loses energy, creating a fan-shaped pattern. Alluvial fans are geological formations that typically occur at the base of mountains or hills. They are created by the deposition of sediment carried by rivers and streams as they exit narrow valleys and enter broader, flatter areas. The fan-shaped deposit is composed of various sized sediments, including gravel, sand, and silt, and it spreads outwards in a triangular or fan-like pattern. In Turkey, you can find examples of alluvial fans in regions characterized by mountainous terrain and active river systems. The Taurus Mountains, Pontic Mountains, and other mountainous areas may have alluvial fans formed by the sedimentation of materials transported by rivers originating from these highland regions. To identify specific locations and characteristics of alluvial fans in Turkey, geological maps and consultation with local geological experts would be valuable. Floodplains. Floodplains are flat, low-lying areas adjacent to rivers that periodically flood. Sediments carried by the river during floods are deposited on the floodplain, creating fertile soil. Floodplains, known as Seldutz Lugu in Turkish, are flat areas adjacent to rivers and streams that are periodically inundated by floodwaters. These areas play a crucial role in natural processes, providing fertile soils and supporting diverse ecosystems. In Turkey, floodplains can be found along various rivers and their tributaries. Here are some examples. 1. Sora River floodplain. The Sora River, flowing in the northeastern part of Turkey, has associated floodplains where seasonal floods contribute to soil fertility. 2. Sakarya River floodplain. The Sakarya River, one of the major rivers in Turkey, has floodplains along its course, particularly in the Sakarya Plain. 3. Yezlermak River floodplain. The Yezlermak River, running through northern Turkey, forms floodplains in regions like the Yezlermak Delta. Floodplains in Turkey support agricultural activities due to the nutrient-rich sediment deposited during flooding. However, they are also vulnerable to flooding events that can impact communities and infrastructure. Effective land use planning and management are essential to balance the benefits and risks associated with floodplains. River deltas. Deltas form at the mouths of rivers where they meet standing bodies of water, such as oceans or lakes. Sediments carried by the river are deposited, forming a triangular or fan-shaped delta. Turkey has several river deltas, where rivers deposit sediment and create unique ecosystems. Here are some notable river deltas in Turkey. 1. Kızılırmak Delta. The Kızılırmak River, one of the longest rivers in Turkey, forms a delta where it meets the Black Sea. The delta is known for its biodiversity and is an important habitat for various bird species. 2. Yezlermak Delta. The Yezlermak River, flowing through northern Turkey, creates a delta before reaching the Black Sea. The delta area is ecologically significant and supports diverse flora and fauna. 3. Gediz Delta. The Gediz River, located in western Turkey, forms a delta near the Gulf of Izmir. The Gediz Delta is an important wetland area and home to various bird species. 4. Sora Delta. The Sora River, flowing in northeastern Turkey, has a delta region near the Black Sea. The delta is characterized by wetlands and plays a role in supporting local biodiversity. 5. Akaya Delta. The Akaya Delta is associated with the Akaya stream in the Antalya region. It is a smaller delta compared to some others but contributes to local ecosystems. These river deltas are not only ecologically valuable but also play a role in supporting local economies through agriculture and fisheries. They are often designated as protected areas to preserve their environmental significance. Glacial processes refer to the actions and movements associated with glaciers, which are large masses of ice that flow slowly over land surfaces. Glaciers are powerful agents of erosion, transportation, and deposition, shaping landscapes through various processes. Here are key glacial processes. 1. Erosion. Plucking. As glaciers move, they pick up rocks and debris from the bedrock through a process known as plucking. The ice freezes onto rock surfaces, and as the glacier advances, it pulls away rock fragments. Abrasion. The glacier's movement causes abrasion as it carries rock particles and debris, scraping and polishing the underlying bedrock. 2. Transportation. In glacial transport, rocks and debris may be carried within the glacier's ice mass. Subglacial transport. Material is transported at the base of the glacier, where it slides or is carried along the glacier's bed. 3. Deposition. Till. The unsorted and unstratified sediment deposited directly by a glacier is called till. Till may include a range of particle sizes, from clay to boulders. Moraines, piles or ridges of till that accumulate along the sides, front, or within a glacier. 4. Landform creation. U-shaped valleys. Glaciers carve out valleys with distinctive U-shaped profiles due to their erosional power. Cirques, bowl-shaped depressions formed at the head of a glacier where glacial erosion is concentrated. Aretus and horns, sharp ridges, aretus, and pointed peaks, horns, form through the erosive action of glaciers on mountain landscapes. Glacial valleys and fjords. Glacial valleys often become fjords when they are flooded by the sea, creating deep, narrow, and steep-walled inlets. 5. Meltwater processes. Outwash plains. As glaciers melt, they release meltwater that carries and deposits sediments, forming outwash plains. Kettles, depressions created by the melting of isolated blocks of ice left behind by retreating glaciers. Glacial processes have left distinctive landforms and geological features on Earth's surface, especially in areas that were once covered by ice sheets or where glaciers currently exist. Glacial cirques, also known simply as cirques, are bowl-shaped hollows or depressions found at the head or upper regions of glacial valleys. These landforms are a result of glacial erosion and are commonly associated with mountainous regions. Here are the key characteristics and formation processes of glacial cirques. Characteristics. 1. Bowl shape. Cirques have a distinct amphitheater or bowl-shaped morphology, often resembling a large, circular basin with steep, rocky walls. 2. Location. They are typically located at the head of glacial valleys, where glaciers originate and flow downslope. 3. Steep walls. Cirque walls are characterized by steep slopes that converge towards the center of the depression. These steep walls result from the erosive action of the glacier. 4. Rocky features. Cirques may contain loose rock debris, called moraine material, that has been eroded and transported by the glacier. Formation process. 1. Erosion. Glacial cirques form through the process of glacial erosion. As a glacier flows down a mountain valley, it erodes the surrounding rock through plucking and abrasion. Plucking occurs when the glacier freezes onto rock surfaces, and as it moves, it pulls away rock fragments. 2. Cirque wall formation. The head wall or back wall of a cirque is formed by the steep, erosive action of the glacier. The glacier effectively scoops out the bowl-shaped depression. 3. Roches mouton knees. The bedrock within cirques often exhibits a smoothed and streamlined appearance due to glacial abrasion. These streamlined rock features are known as roches mouton knees. 4. Tarn formation. Cirques may contain small, glacially formed lakes called tarns, which are often situated in depressions within the cirque. 5. Afterglow features. When glaciers retreat, cirques may become the sites of glacial lakes or alpine meadows, showcasing the lasting impact of glacial processes. Overall, glacial cirques are distinctive and visually striking features that provide insights into past glacial activity and landscape evolution. They are significant components of glacial landforms in mountainous regions shaped by ice erosion. Glacial valleys, also known as U-shaped valleys, are distinct landforms carved out by the erosive action of glaciers. Unlike V-shaped valleys formed by rivers, glacial valleys exhibit a characteristic U-shaped cross-section. Here are the key features and processes associated with glacial valleys. Characteristics. 1. U-shaped cross-section. glacial valleys have a wide and deep U-shaped cross-section, in contrast to the V-shaped valleys formed by rivers. This distinctive shape is a result of glacial erosion. 2. Steep sides. The valley walls are often steep and may exhibit glacial striations and polish, which are caused by the abrasive action of the glacier's movement. 3. Hanging valleys. In areas where glaciers intersect, smaller tributary glaciers may create hanging valleys, which are valleys elevated above the main glacial valley floor. 4. Roches moutonnées. The bedrock within glacial valleys often shows evidence of glacial abrasion, resulting in smoothed and streamlined rock features known as roches moutonnées. 5. Tarns. Glacial valleys may contain small, glacially formed lakes called tarns, especially in depressions or cirques within the valley. Formation process. 1. Erosion. Glacial valleys are primarily formed through the process of glacial erosion. As a glacier advances, it erodes the landscape through plucking, lifting and removing rock fragments, and abrasion, scouring and polishing the bedrock. 2. Plucking. This process involves the glacier freezing onto bedrock, and as the glacier moves, it plucks away rock fragments, contributing to the widening and deepening of the valley. 3. Abrasion. Glacial ice contains rock fragments and debris that act as abrasives. As the glacier moves, these materials scour and polish the bedrock, creating the characteristic U-shaped profile. 4. Transport and deposition. The glacier transports the eroded debris, which can include large boulders and fine sediment. When the glacier melts or retreats, it deposits this material, forming features such as moraines and outwash plains. 5. Post-glacial modification. After the glacier retreats, the glacial valley may undergo further modification through processes like river erosion and sedimentation, shaping the landscape in its post-glacial state. Glacial valleys provide valuable insights into past glaciations and the dynamic processes that shape Earth's topography. They are often prominent features in mountainous regions that have experienced significant glacial activity. Glacial deposition refers to the process by which glaciers deposit or release the sediments, debris, and rocks they have eroded and carried during their movement. Glaciers are powerful agents of erosion, and as they advance and retreat, they leave behind distinctive deposits that contribute to the formation of various landforms. Here are key aspects of glacial deposition. Types of glacial deposits. 1. Moraines. Moraines are accumulations of unsorted rock debris, ranging from fine clay to large boulders, that a glacier transports and deposits along its edges or surface. There are different types of moraines, including lateral moraines, deposited along the sides of the glacier, medial moraines, formed when two glaciers merge, and terminal or end moraines, deposited at the glacier's terminus. 2. Till. Till is a general term for unsorted sediment deposited directly by glacial ice. It can include a mixture of clay, silt, sand, and gravel, often forming a dense, compact material. 3. Outwash plains. As glaciers melt, the water released carries sediments away from the glacier and deposits them in outwash plains. These plains typically consist of well-sorted and stratified layers of sand and gravel. 4. Drumlins. Drumlins are elongated hills or mounds of glacial till. They have a streamlined shape, with a gentle slope on the upstream side and a steeper slope on the downstream side, indicating the direction of glacial flow. 5. Eskers. Eskers are winding ridges of sand and gravel deposited by streams that flowed within or beneath glaciers. They often form sinuous, elevated features in the landscape. 6. Kettle holes. Kettle holes are depressions or pits left behind when a block of ice becomes detached from the retreating glacier, buried by sediment, and then melts, creating a bowl-shaped depression. Processes of glacial deposition. 1. Melting and release. When glaciers melt or retreat, the ice releases the sediment and debris it carries. The sediment is often dropped at the glacier's margins, forming moraines. 2. Sorting. Glacial deposits can range from poorly sorted till, containing a mix of particle sizes, to well-sorted outwash plains, where finer particles are sorted and deposited by meltwater. 3. Stratification. Some glacial deposits exhibit stratification, indicating the layering of sediments based on size and weight. This is often observed in outwash plains. Glacial deposition plays a crucial role in shaping landscapes, creating unique landforms, and leaving behind evidence of past glacial activity. The study of glacial deposits provides valuable insights into Earth's climatic history and the dynamics of glacial systems. Karstic processes refer to the geological and hydrological processes associated with the dissolution of soluble rocks, such as limestone, gypsum, and dolomite, leading to the formation of distinctive landforms known as karst landscapes. Karstic features are characterized by sinkholes, caves, underground rivers, and unique surface topography shaped by the dissolution of soluble bedrock. Here are key aspects of karstic processes. 1. Solubility of rock. Karst landscapes predominantly develop in regions where the bedrock is composed of soluble carbonate rocks, such as limestone and dolomite. These rocks readily dissolve in slightly acidic water. 2. Chemical weathering. Carbon dioxide from the atmosphere combines with rainwater to form a weak carbonic acid. This slightly acidic water percolates through joints, fractures, and bedding planes in the soluble rock, initiating the process of chemical weathering. 3. Dissolution of rock. The carbonic acid reacts with the minerals in the rock, particularly calcium carbonate in limestone, causing it to dissolve. This dissolution is a slow process but can be significant over geological time scales. 4. Formation of caves. As the rock dissolves, larger voids or cavities, known as caves, may form underground. These caves often have unique formations such as stalactites and stalagmites, which result from the deposition of dissolved minerals. 5. Sinkholes. Surface depressions, known as sinkholes, can develop when the roof of an underground cave collapses. Sinkholes vary in size and can dramatically alter the landscape. 6. Subsurface drainage. Karst landscapes often feature subsurface drainage systems, where rivers and streams may flow underground through conduits and caves. These underground rivers can resurface at various points, contributing to the dynamic nature of karst hydrology. 7. Karst springs. Natural springs are common in karst regions, where groundwater emerges at the surface. The water may have traveled through extensive underground networks before reaching the spring. 8. Karst towers and pavements. Unique surface features, such as limestone towers, karst towers, and limestone pavements, can result from the dissolution of rock and the subsequent collapse of overlying material. 9. Karst valleys and gorges. Karst processes can create distinctive valley and gorge systems characterized by the dissolution and removal of rock, resulting in steep-sided, rugged landscapes. Karst landscapes are found worldwide, and notable examples include the karst regions of the Dinaric Alps, the Yucatan Peninsula, and Guilin in China. The study of karstic processes provides insights into subsurface hydrology, cave formation, and the development of unique landforms shaped by dissolution and erosion. Karstic landforms are geological features that result from the dissolution of soluble rocks, typically carbonate rocks such as limestone, dolomite, and gypsum. These landscapes are shaped by the processes of chemical weathering and erosion caused by the dissolution of the rock by acidic water. Karstic landforms exhibit unique and distinctive characteristics. Here are some common karstic landforms. 1. Sinkholes. Sinkholes are depressions or holes in the ground formed when the roof of an underground cave collapses. They can vary in size from small features to large, dramatic collapses. 2. Caves and caverns. Caves and caverns are underground voids formed by the dissolution of soluble rocks. These subterranean spaces can range from small chambers to extensive networks of passages. 3. Palliers. Palliers are large, flat, karstic plains that may form in regions with soluble bedrock. They often result from the coalescence of multiple sinkholes. 4. Uvalas. Uvalas are elongated, basin-like depressions that form when several sinkholes merge. They are common in karst landscapes. 5. Dolines. Dolines, also known as sinkholes or cenotes, are funnel-shaped depressions in the landscape caused by the collapse of surface material into underground cavities. 6. Karst springs. Karst springs are locations where groundwater emerges at the surface. These springs often mark the endpoint of underground rivers and conduits. 7. Karst towers, Sinji. Karst towers are tall, steep, and often pointed limestone formations that result from the dissolution of rock, leaving behind isolated pinnacles. 8. Limestone pavements. Limestone pavements are flat expanses of exposed rock created by the dissolution of the intervening rock material, leaving behind a distinctive pattern. 9. Swallow holes, swallets. Swallow holes are points where surface water disappears into underground cavities. They are common features in karst landscapes. 10. Karst valleys and gorges. Karst valleys and gorges are topographic features resulting from the erosion and dissolution of rock, creating steep-sided and rugged landscapes. 11. Subsurface drainage networks. Karst landscapes often have complex subsurface drainage networks, with rivers flowing underground through caves and conduits. 12. Tufa deposits. Tufa deposits can form in karstic settings when calcium-rich water emerges at the surface and deposits calcite, resulting in unique formations. Karstic landforms are found in various regions worldwide, and the term karst is derived from the Kras region in Slovenia, known for its limestone karst landscapes. The study of karstic processes provides valuable insights into hydrology, geology, and landscape evolution. Turkey is home to diverse and extensive karstic landscapes, featuring a variety of landforms shaped by the dissolution of soluble rocks, primarily limestone and dolomite. Here are some notable karstic landforms in Turkey. 1. Cappadocia fairy chimneys. Cappadocia, located in central Turkey, is renowned for its unique fairy chimney formations. These are tall, cone-shaped rock spires created by the differential erosion of soft volcanic rock atop a more resistant limestone base. 2. Pamukkale. Pamukkale, meaning cotton castle in Turkish, is a UNESCO World Heritage Site known for its terraces of travertine, a type of sedimentary rock deposited by mineral-rich thermal waters. The terraces create a visually stunning, white landscape. 3. Saklıkent Canyon. Saklıkent Canyon, situated in southwestern Turkey, is a deep, narrow gorge formed by the erosion of the surrounding limestone rocks. Visitors can explore the canyon and its cold, fast-flowing river. 4. Karain Cave. Karain Cave, located in the Antalya region, is a significant archaeological site within a limestone hill. The cave has provided evidence of human habitation dating back to the Paleolithic era. 5. Gurame underground cities. Gurame and the surrounding Cappadocian region are known for their underground cities. These subterranean complexes were carved into the soft volcanic rock and served as hiding places during times of invasion. 6. Aladağlar National Park. Aladağlar National Park, in the Taurus Mountains, features karstic topography with limestone peaks, sinkholes, and underground caves. It is a popular destination for trekking and climbing. 7. Sahinkaya Caves. Located in the Sivas province, Sahinkaya Caves are a series of karstic caves formed by the dissolution of limestone. The site is known for its diverse geological features. 8. Karayinsar Lake. Karayinsar Lake, near Bodrum, is a karstic lake surrounded by limestone hills. The lake's water source is connected to underground karstic formations. 9. Krakos Springs. Krakos Springs in Antalya is a group of karstic springs emerging from the ground, creating a picturesque landscape. The site is known for its clear waters and surrounding greenery. 10. Mersin Sinkholes. Mersin province has several large sinkholes, which are surface depressions formed by the collapse of underground caves. These sinkholes are characteristic of karst landscapes. The karstic features in Turkey showcase the country's geological diversity and offer both natural beauty and historical significance. They attract tourists, researchers, and adventure enthusiasts interested in exploring these unique landscapes.